contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the 2 bags is selected at random and a ball is drawn from the bag which is found to be red. Find the probability that the ball is drawn from the first bag. First of all, which theorem we have to make use of? Which theorem? Is it total probability? Is it conditional? It's Bayes. We have to make use of Bayes theorem, wherein we already have the event which is favorable to us, but we are trying to figure out from what is the cause of it, or we are trying to put a number on that basically. Okay, so here too we'll make use of our Venn diagram. So this is the first event and that's your second event. First selection of bag actually, in this case. And over here we have ball selection. So selecting the bag, what are the chances? There are 50-50 chances. There are 2 of it, either this or that. They are equally favored. Not flavored, sorry, favored. So we have bag number 1. This is bag number 2. In the first bag, we have 4 red, and 4. So there are equal chances of them. And in the second bag, we have 2 and 6. So we have 4 red, 4 black. Here we have 2 red, 6 black. Again, within this space, you can have any number, not an issue. So we need to, if you draw this particular thing, we are pretty much done. Okay, right? It's a very simple diagram, right? Now, so I hope that's sunk in. So we are talking about what are the chances that we happen to pick bag 1 and from there we already have a red ball. So basically, what is the probability of bag 1 being selected given we already have a red ball as our answer, right? And this is given by our Bayes theorem, which tells probability of B, or okay, I'll directly write the formula. What formula do you generally? Okay, I use this itself. The probability of B1 into probability of red from the bag 1 divided by, as per total probability theorem, B1 into probability of red. What are the chances that we'll get a red? Plus probability of B2 into probability of us getting a red from the bag 2. Okay, and now all you have to do is substitute. So first is probability of a favorable event is number of event in that favorable event, and the number of outcomes, not event, sorry, number of outcomes in the favorable event divided by number of outcomes in your sample space, right? That's the first formula. Second formula is probability of B given A is number of events in A and outcomes in A and B, that is common, divided by number of outcomes in A. And all we have to do is substitute, right? So in the numerator, we have B1 is half. So I'll go with, I'm confused to go with fraction or decimals. I'll go with fraction itself. 1 by 2 into probability of red in B1. Red in B1 is 4 by 8. Again half. Divided by the same set of number. So you can actually directly write it 1/4 because it's easy calculation, right? Plus probability of bag 2, that is half. Right? There are equal chances of this happening, 0.5 and 0.5. Basically, this is 1, 1. Let me not do 0.5 and confuse you guys. This is 1 and 1. And in this case, there are 2 out of 8. So 2 out of 8. There are 2 red balls out of 8 balls. Let this sink in. This is the answer. After this is just a matter of calculation. Okay, 1 and 2. 2 and 2 gets cancelled. So this is 1/4 divided with, yeah, this is a good representation. 1/4 and LCM is 1/8 over here. So this is 2 plus 1/8. So 1s are 2s are. Okay, denominator, denominator. I hope you guys know all of this. So this is basically 2/3. Yeah, right here itself. 2/3. That's it. So we'll just write a statement. The probability that the ball is drawn from first bag is 2/3. Probability that the ball drawn is from first bag is 2/3. Such weird answers we will get, You won't be even able to think of just like that. Okay, what are the chances that we happen to pick a first bag and we got a red already? It's a weird thing if you think about it, actually. Yeah. So the whole fun is this diagram, guys. If you understand this diagram, you're pretty much done.